we want to show that the integral from 0 to -1 to 1 of 1 minus x squared quantity to the power of n dx is bigger than or equal to 4 over 3 square root of n, where n is some positive integer. And before we show that, we will prove Bernoulli inequality. Right? As long as a is bigger than or equal to -1, then we have the following inequality. So we want to show that 1 plus a quantity to the power of n is bigger than or equal to 1 plus n a, as long as a is bigger than or equal to -1. All we have to show is that 1 plus a quantity to the power of n minus 1 is bigger than or equal to na. Right? That's all we have to show. In other words, all we have to show is that, because 1 can be written as 1 to the power of n, so we have the formula of the difference between nth power. Right? So therefore, 1 plus a minus 1 times quantity of 1 plus a to the power of n minus 1 plus 1 plus a to the power of n minus 2. Power just keeps reducing all the way down to power 0. Then all the way down to 1 is bigger than or equal to na. That's all we have to show. Right? In other words, this is just a times quantity 1 plus a to the power of n minus 1 all the way down to 1 is bigger than or equal to na. Right, that's all we have to show. Now, if a is equal to 0, what's going to happen is that left-hand side is just 1, right-hand side is also 1, so inequality obviously true. Right? So what if a is bigger than 0? Right? What's going to happen? When a is bigger than 0, then of course 1 plus a is bigger than 1. Right? If we raise to the power of k on both sides, some positive integer, then we obviously have 1 plus a quantity to the power of k is bigger than or equal to 1. Right? Any positive k integer k is okay. Now, the question is how many of them are there? Right? 1 plus a to the quantity of some power of some positive integer. How many of them? There are n terms in here, right? Every term is bigger than or equal to 1. Of course, when you add them up, the overall quantity will be bigger than or equal to n. Right? So a times the quantity is bigger than a times n. Really true. So in this case, it's obviously true, right? Obviously true. Right. Also because a is positive, right? So this quantity is bigger than or equal to n times a on both sides. Inequality maintains the direction. And also in the case of a is bigger than or equal to -1 and smaller than 0, right? Smaller than 0, because we've discussed it in the case of 0 and bigger than 0. In this case, right, what's going to happen is that 1 plus a is going to be smaller than 1 while bigger than or equal to 0, right? But still positive, non-negative, but smaller than 1. So in this case, if we raise to the power of some positive integer, it should still remain true, right? Smaller than 1. Now, again, how many, right? N terms in here. Every term is smaller than 1, right? And bigger than or equal to 0. Right? So the whole quantity in here is actually in between 0 and n, right? 0 and n. If we multiply multiply by a on both sides, right? Because first of all, without a, we should have this quantity is smaller than or equal to n, but because a is negative, therefore we just change the direction of the inequality, right? So bigger than or equal to, multiply by a on both sides. So also true. Also true. So as long as a is bigger than or equal to -1, then we have the Bernoulli inequality. And now that we have the Bernoulli inequality, so the original integral is actually, the integrand is actually even function, right? So this original integral can be written as twice of the integral from 0 to 1. 1 minus x squared to the power of n dx, right? And before we apply the Bernoulli inequality, well, first we have to change the boundaries, right? We're going to change 1 into 1 over square root of n, because motivated by this result, right? Square root of n on the bottom. So if we change 1 into 1 over square root of n, that means we've shortened the interval, right? Because the integrand is x is in between 0 and 1, so therefore the integrand is non-negative, right? Therefore, if we shorten the interval, then the overall integral will be reduced. Okay? Bigger than or equal to twice of from 0 to 1 over square root of n, right? We're safe to do so because integrand is non-negative. If the integrand changes sign, then we're not safe to do so, right? Now, having this result, we're going to use Bernoulli inequality now in this step. And bigger than or equal to twice of integral from 0 to 1 over square root of n. And we're going to check if condition is satisfied. If a is bigger than or equal to -1, right? So we're going to see if negative is it bigger than or equal to -1? I believe so, right? Because x this time is in between 0 and 1 over square root of n. N is some positive integer. Therefore, 1 over square root of n is definitely smaller than or equal to 1. Right? So therefore, x squared is still bigger than or equal to 0 and smaller than 1. And if we add a negative sign, negative x squared, this time change the direction, is bigger than -1. Smaller or equal to 0, right? So really, bigger than or equal, yes. So this time it's really satisfied, right? Really bigger than or equal to -1. Therefore, Bernoulli inequality, right? This is really bigger than or equal to 1 plus na, right? That is 1 minus n x squared with dx. Right? So it's easy for us to find the antiderivative. That is twice of, what do we have here? So we have x, we have minus third of n times x to the power of 3. And we're going to evaluate it from 0 to 1 over square root of n. Right? And this time it's going to be equal to twice of x becomes 1 over square root of n and minus third of x cubed. X 1 over square root of n cubed, right? And 1 over n cancel out, and still I have 1 over square root of n. Still I have 1 over square root of n. And x becomes 0, so 0 minus 0, still 0, so we're fine. So in the end, we have this. So that is equal to twice times common denominator, right? 3 times square root of n multiplied by 3. 3 minus 1, that is 2. Right, eventually we have 4 over 3 square root of n.